Hey everyone, thanks so much for coming to see the Beneath the Surface Day 6 slides. I'm going to turn my picture off right now, but thanks for checking in. So today in class, we got out our water quality packets. Remember, you need to keep track of that. Don't lose it. We'll use it for several weeks, and you'll need to turn it in at the end. You're going to answer the warm-up questions, and then you'll make sure that you have your computer out in class because we have some computer things we're going to do. All right, warm-up questions. Which can hold more dissolved oxygen, cold water or warm water? So think back or look at your notes and think about that. The answer is cold water can hold more dissolved oxygen. So that's good for animals because they need oxygen to breathe. And so cold water is great because it holds a lot of dissolved oxygen. All right, if more aquatic plants are added to a body of water, would you expect the dissolved oxygen to go up or down? Think about that. What do plants do when they are in the sun? They do photosynthesis. What does photosynthesis give us? It gives us oxygen. So if we put more aquatic plants in, we're going to add more oxygen to the water. And it's dissolved oxygen when it's in the water and available to our fish. Okay, so we expect the oxygen to go up. Do fish add or remove oxygen from the water? Well, let's think about that. The fish are hanging out swimming. Fish need to breathe just like people and other animals. And so we know the fish still have to breathe in oxygen, even though they're getting it differently from how we humans do. They're taking water in through their gills, and then their gills are extracting the oxygen. So if they are breathing and living happily in the water, they are removing oxygen because they are breathing in that oxygen and using it. All right, click. There's my click. And then what is one cause for a body of water to become more acidic? So you have to think back to your videos that you watched and your little blurb that you read, or you can look at your notes. So water can become more acidic if it's exposed to acid rain. So in the moments after an acid rainstorm, or if there's regularly a lot of acid rain, the acidity of that body of water is going to go down. The pH number is going to go down, which means it is more acidic. Also, decomposition. So if we have kind of dead things in the water, that can make the body of water become more acidic as well. All right. So this was our fun think about this question. What new class would you like to have start at school? So if you're in class today, then you'll chat with friends about this and chat with us. And then if not, you can just think about it for fun. All right, our learning targets today, we're going to learn about water quality indicators. How are we going to do it? By reading and watching videos, by practicing, and by sharing data. So we are collaborating. And then why are we doing it? It's so that I am able to make accurate observations about my ecosystem. Each one of you will be able to make observations and then hopefully, eventually, make changes to keep your ecosystem healthy. So for the next 15 minutes in class, you're going to have completed all of your water quality slides in the folder from last class. You might have to back up and go to day 5 in your folder. Please make sure you've gone through all 4 of those slide sets and make sure you've filled in your notes on your packet. Then check your work on your notes. There will be a link in today's folder. This is day 6. Check your notes and make sure that you wrote down true information like what is in our notes key. Third, you're going to practice any water quality test you didn't complete last class. Just remember, as you are doing any water quality testing, you have to have your goggles on, and you always want to pick up your instruction sheet and carry it with you when you're testing your water quality. Finally, you're going to use the Quizlet link that is in today's folder. Click through those flashcards a couple times and make sure you're pretty comfortable with how the flashcards work. And then you can try a matching activity or a test activity or one of the activities Quizlet offers you just to keep practicing. So That's a lot to get done in 15 minutes. Do your best. Of course, we're not waiting 15 minutes. Nope. All right, so after you've done the Quizlet practice, you should be able to answer these questions. So, and these are similar to our warm-up questions. Which can hold more oxygen, cold water or warm water? Think for a moment. Try to do this without checking your notes. It's cold water. That's going to hold more oxygen. Which type of organism adds oxygen to the water? How do we increase oxygen? That's going to be increasing the dissolved oxygen, of course. Are we adding plants or animals to do that? Well, plants go through photosynthesis. They give us oxygen. Animals would actually decrease the oxygen in the water because they're using the oxygen, breathing that in, and giving out carbon dioxide. All right. True or false, when aquatic animals breathe, they take oxygen out of the water? Well, silly me, I just said it, didn't I? So is that true or false? Animals breathe, they take oxygen out. That's true. Just like when we breathe, we also use oxygen. And finally, which type of water contains more oxygen? Moving water or still water? So think like a rushing river or a pond. So you can imagine the rushing river is kind of rushing through the air, right? There's more of that water touching the air, and air has oxygen in it. And so the moving water is always going to have more oxygen than the still water. Okay. Well, not always. I suppose it depends on the plants and things like that. But most of the time we assume moving water is our answer. All right, we're going to answer these questions too. Again, your notes and all of the information you looked up in your slide decks, and also the Quizlet practice should set you up well for this. We have a pH scale up top here. Remember, our neutral number is 7, and our acidic numbers go down. So lower numbers are acids, and higher numbers are bases. All right, so if a pond had a pH measurement of 3, would that be considered acidic or basic? So we look up here on our scale. If we can't remember, 7's the middle. Anything lower than 7 is an acid. Okay, so that would be acidic. Name one way that a body of water could become too acidic. We've talked about this a time or two. So of course, if there's acid rain that's being exposed to a body of water, or if we have decomposition. And third, what is the healthy pH range for aquatic organisms? Sorry, I'll try to change that in a minute. So the healthy pH range, this is posted all around the classroom with a bright yellow banner that says normal abiotic ranges. But we're going to say that our healthy pH range, generally we're going to say 6 to 9. Some sources are going to show you 6.5 to 8.5, but we're generally going to call it 6 to 9. All right. Now, thinking about your nitrite test kit, that's where you put 5 milliliters in, 5 drops in, and wait 5 minutes, and it will change colors. What did we say is a healthy form of nitrite? I mean, the healthy parts per million. We like it to be less than 1 for sure, okay? So nitrites are bad for our organisms. They are a form of nitrogen. So not all forms of nitrogen are bad. It's just that nitrites are not good for our creatures. All living things do need nitrogen to help make proteins. They just need that nitrogen to be in a better form than nitrites. Okay, nitrites should not measure greater than 1 part per million. And if you remember from your reading, you learned about what turns bad nitrites into a good form of nitrogen. That's bacteria. That's going to help turn the bad nitrites into a better form of nitrogen that the ecosystem can use. All right, so thinking about our water clarity pictures, we went 1, 2, 3, 4, 5 with that clarity. What does water clarity measure? It does measure how clear that water is, and it actually is measuring how far down the sunlight can travel through the water. Because if we have particularly unclear water and we have the sun up above it, The sunlight is not going to get down very far, so any plants down low are not going to get sunlight, and they're not going to be able to do their photosynthesis magic, and it's not good for the ecosystem. So we prefer clearer water because the sunlight can get down further. Why is clearer water better for aquatic plants? It's because clearer water allows the sunlight to get down there so that they can do their magic photosynthesis, which is not magic, it's science. Then, number 3, what is something that can enter the waterways and decrease the clarity of water? Well, one of the things that you read about, hopefully, was, or it maybe even thought about when you were doing your gizmos, is if we have activities that increase the amount of sediment that runs into the water, it's going to make the water less clear. Also, fertilizers that humans are using for lawns and things, they're going to have an effect on the clarity of the water too. How do you think water clarity and dissolved oxygen levels are related? So think about that. If I have low number, if I have good water clarity, it's pretty clear. That means the sun is getting down to my plants, even in the bottom. And so my plants are getting sunlight, which means they can photosynthesize, which means they can produce oxygen. So increased clarity means that we have increased photosynthesis, which means we have increased dissolved oxygen. All right, you're going to try for real if you're in the classroom, and if you're at home, next time you come to the classroom, you're going to work on this for real, and you're going to, you're going to want to get data. If you were absent, you want to get data from your table mates because you want the data for your ecosystem. All right, so on, if you're watching this on Friday, it's going to be 9/29. If you're watching this on Monday, it's going to be October 1. So just make sure your date is correct if you're watching this video. So day 0, we're going to take our first measurements of our aquatic system, and we're going to actually record everything. So we have not put any animals in or plants in yet. Okay, just as a reminder. So you're going to get to this page in your packet. I believe it's the 3rd piece of paper. You're going to put the date down. Make sure you're putting the correct date. So if 9/29 is not the correct date, please be sure you're putting the correct date. We're going to get the temperature of the room and the temperature of the water. So if you all ask me or your teacher what the room temperature is, we have thermometers in the room and we can tell you, and maybe we will remember to write that room temperature on the board. Remember, you want that information in Celsius degrees, not in Fahrenheit. One person at your table is going to be doing water temperature and water clarity. One person is going to be taking measurements for dissolved oxygen. One person is going to take pH measurements, and one person is going to measure those nitrites. So remember, if you don't have all 4 people at your table, you're going to try to have whoever finishes their first test work on whatever remaining tests you have. You want to try to get all of these measurements anytime you're taking the tests. Okay, so the jobs for today in class for this would be day 6. If you are person A, and remember you can look on the front of your packet to see what letter you have. If you're person A, you're in charge of temperature and clarity. If you have letter B, you're in charge of dissolved oxygen. Letter C, you are the pH tester. And letter D, you are the nitrite tester. Okay, remember, anytime you're going up to the testing area, you're going to have your goggles on over your eyes, not just on the top of your head. Each person is going to complete their task using the directions on the task card. So you want to have those task cards out in front of you. When you finish your test, be sure your station is cleaned up as much as you are able to clean it up. Pretty much the only thing you can't take care of at that time is you probably aren't going to put the top back on, but you could, because if somebody else is testing, they can certainly take the test off too. Okay, then you're going to make sure you're cleaned up. You can return to your seat and you're going to share your data with everyone else at your table. Make sure you get all of the shared data as well. All right. So by the end of class, you should have taken information for day 0. And then you're going to take a look at your numbers. Were all of your abiotic factors in the normal range? Remember, you might need to look around the classroom at our normal range sheets. So if they weren't, which ones were not normal range? You can circle them or highlight them to make a note to yourself that something was not normal. And if you had some that were not normal, try to think about why that might be. Or if they were all normal, try to think about why you think they're all normal. Just a little bit of like bullet point comments or something. All right. Now look at this graph. Remember, anytime you have a graph, you want to read the words that are on it. You want to read the labels on the axes and make sure you know what you're looking at. Then you want to try to figure out what is the graph telling you. I see that this is oxygen solubility in water at various temperatures. So solubility, you have sol like dissolve, okay? So soluble, something is dissolvable. So this oxygen solubility is going to be related to dissolved oxygen, right? Okay, when I look here, I have different temperatures. I started at 0 degrees Celsius, and I can see the word temperature, right? 0 degrees Celsius all the way up to 35 degrees Celsius, which is pretty warm. And I'm looking at my y-axis here. That is dissolved oxygen in milligrams per liter. And I see that I have some numbers that are going up. And so my dissolved oxygen is highest on this chart right here at 14 when I'm at 0 degrees Celsius. Okay, so we have our highest dissolved oxygen at 0 degrees. What is the chart telling you? What is this graph telling you? Think about it. And try to complete this sentence. As the temperature increases, the dissolved oxygen, blah, blah, blah. What is the dissolved oxygen doing? As temperature increases, dissolved oxygen is going down. Always, 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 if you have a graph or a table or even an image, read your captions, read the axes and their labels, and try to take a guess about what you think the graph or the table or the picture or the image or whatever is telling you. All right. Again, which body of water, looking at these two, is going to have more dissolved oxygen? We have moving water and we have still water. So think back. Which one is exposing itself to lots of air which has oxygen in it? That's that guy. Looking at these two, which one do you think has more dissolved oxygen? In this case, I see mostly fish with one little plant. This guy, I see some fish, and then I see tons of plants. And I see a lot of running water here. So I'm going to say it's this one. Okay. I have a beach scene and I have a glacier area scene. So which one of those is going to hold more dissolved oxygen? Stretch your brains. Think about what you know. Which one holds more oxygen, warm water or cold water? It's cold water. Okay, so sometimes we'll phrase our questions a little differently. Just try to think about what you know. What factors affect water temperature? The sun and the temperature of the air around us is going to affect our water temperature, right? So the seasons are going to affect our water temperature overall, like spring, summer, winter, and fall. So you know that the water temperature in a specific area is likely going to be colder in the winter and warmer in the summer. Okay, so you can also think about a time of day might affect the water temperature. It probably depends on how deep the water is. I guess what I'm saying is if you're in a pool or something, sometimes first thing in the morning, if you are on swim team or have ever gone swimming bright and early in the morning, sometimes it's cooler in the morning because it hasn't been exposed to the sun all throughout the day. Sometimes it's warmer by the end of the day. Okay. How would paved surfaces affect the temperature of a local stream? You did have a question about this in your packet, and this was one just to think about. So I know that I've got paved surfaces near this stream. These dark surfaces in the sunlight, especially in the summer, they're going to get pretty hot. So if I have rainwater that touches the pavement surfaces, it's going to heat up just by touching those hot asphalt surfaces, right? So as it runs off, I now have warmer water going into the nearby streams and ponds, so it could raise the temperature. All right, think back again about our pH scale. So we want to know, what is that healthy pH for our aquatic ecosystems? We are saying, of course, neutral is 7. So we're going to say 6 to 9 works for our ecosystems. All right. If a body of water measured a pH of 4.2, is that going to be acidic or neutral or basic? Well, neutral would be 7. Anything lower than 7 is an acid. Anything bigger than 7 is basic. Okay, so 4.2 would be acidic. How does water become more acidic? How does it end up with a lower pH? We can have acid rain. We might have fish breathing in the water that actually can decrease the pH. And we also might have decomposition, and that's going to lower the pH also and make it more acidic. All right, so nitrites are bad, but we know our creatures need nitrogen to form proteins. So how are we going to turn the bad nitrites into a good form of nitrogen? We do that with bacteria. So we have good bacteria that can be added to the system that will turn those nitrites into something good and usable. So bacteria turns bad nitrites into something good for us. All right, now CO2 is the byproduct that you breathe out after you have breathed in oxygen. So as the amount of CO2 in the water increases, so fish are breathing and releasing CO2, what happens to the pH? Remember, in this case, if the fish are breathing, they are using oxygen. Okay, they are putting CO2 into the water. So as CO2 increases, our pH is going to become more acidic. As the fish are breathing, the pH goes down. Okay, these are some fancy chemistry images that also talk about that. And when I've said per hydrogen or potential hydrogen, when we're talking about acidity, that H plus, that's a hydrogen ion that's hanging out, maybe going to be pulled away. All right, so again, are nitrites good or bad? Nitrates, are they good or bad? We want less than 1 part per million. So there's a hint, right? They're harmful. They are harmful to our creatures. Why does water clarity matter? Think back. Matters because if the sunlight can get all the way to these plants, that's a good thing because the plants can perform photosynthesis. If the water is not very clear, those plants are not getting very much sunlight. They are not going to be able to do their photosynthesis as efficiently, which means dissolved oxygen is going down. And we know we like dissolved oxygen in our aquatic ecosystem. The clearer the water, the more sunlight can get to the plants so that they can perform photosynthesis. All right, please check in your Schoology folder now, and hopefully you've practiced your Quizlet. Hopefully you've looked through your notes and you've made sure they are correct. You are going to complete this quizzes using the link in Schoology. Okay. After you complete that quizzes, here are some things to think about if we have time. The student says, OMG, the dissolved oxygen is at 3.2. What do I do? This student says, the nitrites level is at 2. We want it to be less than 1, right? Is everything going to die? You would think he would be frowning a little, but maybe he's already knowing he's going to be able to fix that, right? This guy says, the pH is 5.1. Oh no, how do we fix this? So they're smiling because they know they can fix it. So find this page in your packet. What do we do if? So what do we do if the water temperature is too high? What do we do if the water temperature is too low? Dissolved oxygen, it's not going to be too high. We like dissolved oxygen. So you're going to only think about what would you do if the dissolved oxygen is too low. If your pH number is too high, that means it's too basic. If it's too low, it means it's too acidic. So what would you do? Or what could you do? Nitrites, of course, if they're too high, what would you do? If they're too low, what would you do? And then water clarity, what would you do if the number for the water clarity is too high, which actually means it's not very good, right? Because if you think about that scale, 1 was super clear water and 5 was super murky. What are you going to do if it's too murky? Okay, it's never going to be too clear because we love it when it's clear. So if you found that page in your packet, I want you to use your notes and work with your table only for 4 minutes to come up with a few logical ideas of how you might fix the problems. Okay, particularly look at water temperature and dissolved oxygen because I don't think you'll have time for everything. Okay, use logical and reasonable ideas. We don't get to call on gnomes and fairies and leprechauns to fix our problems. We have to come up with logical things, right? Okay, 4 minutes working on that. If you have time, you're going to try to come up with some logical ideas that also might fix pH. Okay, and then we're going to see if you can share out, if we have time, some of your solutions. We might not have time for that, and so in any case, give yourself some minutes so that you can complete the exit ticket for today. It's Beneath the Surface, Day 6. You have 2 attempts, so if you don't get everything absolutely correct the first time, go through any problem that you didn't get right. It'll say 0/1. If it was worth 1 point, it's giving you 0 points. Try to figure out what the real answer is before you take your second attempt. Okay, so sometimes you're going to have to refresh Schoology to get it to give you a score. Schoology is sometimes a little temperamental. Please work through this. You may use your notes, but no talking for this one. I want you to see what you can figure out all on your own, and you do have 2 attempts. So thanks again for watching, and I hope this was helpful.